Hi, good afternoon, everyone. I hope my voice is audible to all the participants. Good afternoon for today's session. In today's session, we will be having discussions on machine learning. In the previous sessions, you all have done a lot of things like setting up data IKU. We have also started with working on a project, which is a house price prediction project, which is a sample project which we are just taking in order to understand what response variables are, what independent variables are, as well as our major objective is to come up with a project for telecom products. So for telecom, we have took a data set, which is the data set from Talking Data, and out of which we have to identify the user demographics depending on certain information available from them, which includes information like they have various information available, uh, the mobile handset information, and there are various other information like application labels and various events. So we'll be working out on that particular concept today. So just give me a minute before we start the session. Kindly set up your IDs and everything, and we'll quickly start in a moment. Okay, so I believe my voice is audible to everyone. Please confirm me on chat so that we can begin our session. Okay, great. So yes, I'm able to receive all the chats here. Good afternoon, everyone. Okay, so let's go for it. So what we will be doing in today, we will start with our project. Initially, we'll have a look with the complete stages of machine learning with house price prediction data, which has been provided yesterday. And followed by that, we will be implementing our telecom data. Okay, that means we will be analyzing the telecom data. So let's go for it. So here, it start with our data IKU. So I hope your data IKU account will be available with all of you. I need to quickly access that from my Gmail. So just you need to give me a minute. Okay, so that's my account here, cloud.dataiku.com. You all have to log in into your account. And once you guys are done logging, you will be available with the project which we started yesterday. So I have created a project known as Devanshu Shukla House Price Project. This is just to give you a quick understanding of how the flow works, how Data Science Studio works, and whatever we can do with the user interfaces, all the similar stuff we can implement using uh, our Python programming notebooks also. Okay. So in order to do that, let us just quickly go to the flow and see what we have. So we have got our housing data set available. And yesterday we have also created a collab file, collab.research.google.com. We have created a notebook where we have read the housing data set as well. And the name of the project was House Project, which we have taken. So now here we have two options. In one, we can work out on the user interface format, and second, we can work out on the command based, the Python programming language based implementations we can do. Okay. So now, once it gets connected, we are going to quickly proceed with the further steps of machine learning. Now, as I believe everybody is clear with the major objective of our this session, and it is to extract knowledge from the data set available. Now, how we can extract the knowledge from the data set available? We have to follow a benchmark, and the benchmark is known as selection of the data, pre-processing the data, transformation, data mining, and finally interpretation and evaluation. Okay, I'm going to write the steps for you here so that it is clear to everyone. So suppose you have the data set available. You're going to pass this data set with the following stages. The first stage is selection, followed by pre-processing, followed by transformation, then data mining, and finally interpretation and evaluation. Okay, so this is something which needs to be implemented. Now, how we will be using this, and within each stage, what all we have to do, that is what we are going to understand first. So when it comes to selection, there is a couple of things which you guys need to do. Under selection, we identify independent, first we identify the dependent, comma, independent variables. Okay. Now, what is the meaning of dependent variables and independent variables? Dependent variables are something which you have to predict. So suppose we have the housing data set in which we have certain features, and I'll just quickly show you the features by double clicking on the housing data set. Once we double click on the housing data set, you can see that we have multiple variables available over here. One, we have the price, and other we have lot size, bedrooms, bathrooms, air conditioning, and up to preferred area. So we can say we have to predict the price of a house, so we can make this variable as dependent, and all the other variables which will be used to predict the price will be considered as independent variables. Okay, so we are going to call all of them as independent variables. So the first process is selection of dependent and independent variables when we start machine learning. This we can do both ways. We can do it programmatically, as well as we can do it in the user interface format with Dataiku also. Okay, so how can we do that? Let's have a quick look. So if I quickly take you back to the flow, okay, and here over the flow, so we got the dependent variable as well as the independent variables and the other stuff. Okay, what next we need to do? Then once you have selected your dependent variables and independent variables, you have to perform analysis. Okay, sorry, you have to perform pre-processing. What do we do generally in pre-processing? Pre-processing is something to clean the data. Okay, clean the data and make it analysis ready. So certain steps has to be implemented here. And what are the steps? So there are some following steps which we all need to implement in order to process the data. So the first is find and replace missing values. Okay. Then convert text into numbers. This is the second thing which we need to do. So in case if in a data set, if you have some missing values, then we have to replace those missing values with mean, median, or any other value. As well as in case if we have text in the data set, then we have to convert that text into numbers. Because you all have to understand, machine learning is all about mathematical equations. And on a mathematical equation, you can only put numbers. So if you have some text data, you won't be able to put it onto algorithms and you won't be able to analyze the results. So in order to quickly analyze the result of the text, we have to convert that text into a number, and then that number has to be given to a algorithm. And once the algorithm gets executed, we get the result. Then we map or trace back to the actual text value, which was represented by that number. Okay. So that we will be doing it. So these are some of the important steps, how we can find and replace the missing values, how we can convert the text value into numbers. This is the second process which we are going to do. Third is transformation. So generally what happens is, mostly the variables are of different scale. Okay, mostly variables are of different scale, and different scale as in different range. Okay, so we have to convert. So we have to convert variables of different range into a common scale, or you can also say into a common range. And the common range is between 0 to 1. So suppose currently in your data, you have a price value which is in thousands. Then you have bedrooms which is in the range of 1 to 9. So it is going to be very difficult if we map both of the values on a map. It will be very difficult to compare their relevance. So what we have to do, we have to convert all the values or all the variables of different range into a common range between 0 to 1, so that we can have a comparison between them. And with this comparison, we can actually identify if our price variable is dependent on other variables listed in the data. Okay, and why do we calculate the dependence? We do calculate the dependence so that once we get to know if one factor is influencing the decision or the dependent variable either positively or negatively, so it can actually help calculate that variable, calculate the dependent variable. Okay, so something we do by converting the range of different scale into a common range, and that process is transformation. Followed by, you perform the data mining techniques, and in the data mining techniques you have to apply mathematical algorithm on your data set. Okay, and finally we have to plot the graphs and evaluate using loss and accuracy, and evaluate effectiveness of algorithm / model using accuracy and loss. Okay, so these are some of the steps which we need to implement in using the knowledge discovery process: selection, pre-processing, transformation, data mining, and interpretation and evaluation. So let us just quickly understand how we guys can actually make use of housing data set in order to implement all these 5 stages and extract the knowledge. So let me just clear the drawings here, and we'll now quickly start with the process. Okay, so first of all, what you all have to do, you have to get started with the first step of selection of the data, pre-processing it, and finally transforming the data. And once the data is transformed, you have to perform analysis on it. Okay, so first let us do it with user interface so that it will be clear. So we can select the housing data set. Once you select the housing data set on the flow, then on the right hand side, you can quickly see a menu where we have a lot of options. And the first option which we have to get started is with preparation option. So we have to prepare the data, and preparation of the data means we have to remove the null values. This can also be known as pre-processing of the data. Okay, so you may be asking, how do we select the data? So selection of the data we do once we select the algorithm that which variable we want to predict. So that we will be doing a little later. So as of now, we are starting with the pre-processing of the data process. And once our data will be pre-processed, it will be ready for machine learning analysis. Then we are going to put that data on different algorithms. Okay. So how do we prepare? Let's have a look. So preparation is very easy. Just you have to select the data set. You have to click on prepare. And preparing means you're going to have the original input data set. You're going to generate a prepared data set after your various options like cleaning the data, replacing the missing data with mean and median, and so on. So let's go for it. Let's create the recipe. Under this recipe, on the left hand side, you have a panel which is very important. Now here on the left-hand side panel, whatever you will be doing in the user interface, automatically a relevant script will be added on the left side of this screen. So now we do have a script and we do have a design sample. In the design sample, we have 546 rows and 12 columns, and the samples are displayed to you here. Now what we need to do, we actually have to convert these with the pre-processing step. So in order to perform the pre-processing, it would always be good initially to explore the data. Okay. And once you explore the data, you will get to know, does any of the columns contain null values or not? And does any of the column contains anything which we have to perform processing, like in case if it is containing text, then we have to convert it into numbers so that our data can become machine learning ready. Okay. So let's have a look. So now, in order to do this, what exactly we want to have? We want to have the selection process and the pre-processing process. And before the pre-processing process, you can also again think of with the graph, which we have discussed at the very start, that you have to identify what happened in data, why did it happen, what will happen in future, and how do you make the best happen. All that 4 steps should also be pretty clear with you. Okay. Now, what we are going to do, let us just quickly perform the pre-processing. So there will be 2 types of pre-processing we need to do. So types of pre-processing, let me just quickly define it here. Pre-processing stages. So first stage will be find and replace missing values. Okay. So if there is a value which is not available, maybe null or none or empty, so we are going to find and replace the value. Okay. And in the second option, what we are going to do, we are going to find and replace null values with mean, median, etc. Okay. As well as the second option would be, we have to convert text into numbers. Okay. So are you all able to execute along with me? Please confirm me on chat if you all are able to execute the steps along with me step by step. Okay. Now here. So what exactly we will be doing? We have to perform the pre-processing part. And in the pre-processing now, we do have the price, lot size, bedrooms, bathrooms, stories, driveway, recreational room, full basement, gas, hot water, air conditioning, and there are some other columns also. And those columns are garage places and preferred area. So now you can see that here you have a price which is of a big range from 4200 to 38,500, 49,500. So this range is in thousands. Then you have the lot size with a medium level range, and then we have very small ranges. We have the value ranges between 1 to 5 or 1 to 6. So here are the bedrooms. These are already integers, so we don't need to do anything over all these 4 columns. Okay. So decimal, integer, we don't have to do anything. But when it comes to text, then we have to replace this text into number. Okay. Followed by Boolean also, you can ignore, or else you can also convert Boolean into 0 and 1 if it is written as yes or no in your data set. So you can see that we have multiple columns as Boolean, which is written in alphabetical representation. So we have to convert this into numbers so that we can perform the analysis well. Okay. Followed by, you will be having more number of variables which has to be transformed and pre-processed, and they will be preferred area and garage places. So garage places is already number, we are going to ignore it, but preferred area is a Boolean character which represents no, which you can also consider as 0. So using that, we are going to convert this into number as well. Okay. So it's very easy to convert this process, because what you are exactly doing, you are preparing your data for machine learning analysis. Okay. So how we are going to do that? We will be converting first we'll find the empty values. So in order to quickly see the empty values, you have the quick column statistics option available over here. So once you click on quick column statistics, you will get the quick statistics like the price ranges in this range. Then you have the lot size range, bedrooms, bathrooms, driveway. Okay. And now in case if you have to check if there is any empty column within the price or in any of the variables, then what we have to do is we have to quickly click and view this data. Okay. So now let's say if I click on the price, so you can see that I've got certain options for price. So first option, which is very important for all of us, is analyze the data. So once we analyze any column of a data, if the data is very large, what you can do, you can quickly check back whether it contains any null values or not. So if the data contains the null values, then it means we have to replace that null values with certain numbers so that we can perform machine learning analysis. Now, let's quickly click on analyze. And in the analyze, by default, you are going to get certain information like, let's say, there are three types of variables, and the current variable which is identified is a numerical variable. Okay. Followed by how many valid rows it has. So it has 546 valid rows, which means all the rows are valid. There are 108 unique rows, okay, which is 19.84%, as well as there is no invalid and no empty. Okay. Now, and here you do have a quick range of your house price data set and distribution of the price. Okay. Now you can see that with respect to this graph representation, we can actually understand that this is the area which can be considered as a high price data, and majority of the cases in your house price data sets fall under this range. Okay. And the maximum value of the houses are nearby $180,000, and the minimum is somewhere nearby 15 to 20 USD. Okay. Now what we have to do, we have actually checked in our data set, we have unique data, but no or none is empty. Okay. There is no empty data. So once the data is not empty, then we don't need to replace it with any other mean median. But in case if you got any column data as empty, then in that case you can replace the empty with mean and median, because you cannot make use of zero in the mathematical equation. Anything multiplied or divided by zero would be anything like either zero or non-reachable. Okay. So that's what we will be doing. We are going to understand how you can quickly identify the empty and you can replace them. So as of now, we don't have any empty. Plus we have certain statistics, and there are certain statistics available over here, which has the minimum value of the price. So minimum value of the price in the complete data set is 25,000. That there is a max value, mean, median, standard deviation, mode, distinct, IQR, and sum. So these are some of the statistical values which have been calculated depending on the data set provided. Okay. Now what we have to do. So we can see that our data is non-empty, which means we have to use this data. But second thing we can do, in case if it is non-empty, we have to check whether it is in text format. In case if it is in text format, we are going to convert it into numbers. Otherwise, we will leave it like mathematics. Okay. So since the first column which we have taken does only contain information of the price of the information, so there is no limit, and what we can do is we don't need to convert it into either the numbers because it's already in the number format. Okay. Next, you can see there are other variables like lot size, bedrooms, bathrooms. They are already numbers and they are not empty. None of the field is empty in these. So finally, we are going to start with the pre-processing of the following columns. So what all columns will be pre-processing now? We will be pre-processing the following columns right from the bathrooms. Okay, right from the stories. So we'll start something from the stories because bathrooms has is already a big integer type. Okay. Then we have stories, Daewoo, recreational, full base, gas, hot water, air conditioning. So in all of these, we have the text information available. One is in the text format. Second one is in the Boolean format. And finally, in the preferred area also, we do have the text data. Okay. So in order to make analysis on this data, we have to convert it into numbers. Okay. So what can be done? So once you have to convert the text into numbers, there are two types of conversions. One is convert binary text into 0 and 1. Okay. And second is to convert categorical variable into, okay, then you have to convert the categorical text into some common values. Let's say if we have 4 categories, so we are going to represent it into a range of 1 to 4, let's say. Okay. And once we are going to get the common ranges of representation, then we can actually compare both of the images and we can grab the insights out of it. Okay. So I hope this is clear to all the participants still here, that in order to process the data, first we have to perform the analysis. And for analysis, we have to make sure, in case if we are trying to pre-process this, uh, you have two ways. One is conversion of binary text. Second is the conversion of categorical text. Okay. So how we can do that? It's very easy to do that in the preparation section. And how you can do that? Simply, you have to select the column. Let's say all the 3 values before this was fine, but now we have to convert the stories. So to convert the stories, you can click on stories, you can go to analyze, and once you reach analyze, you're going to see the different kinds of column values available. So we can see that under this we have only 4 categories, 2, 1, 4 and 3, but all of these are written in alphabetical order. What do we need to do now? For making this dataset machine learning ready, we have to convert these text values into numbers. And in order to do that, it's a very easy process. Just you have to double click on the value, and if it is written as 2, just change it to integer 2. Okay. So we have converted the integer 2 into number 2. Then we have integer 1, we convert it into 1. So why we are converting them into mathematical numbers? So that these values can be used okay, in when you will be performing machine learning, because machine learning contains mathematical equations, and mathematical equations can only be applied on numbers. You cannot apply them on the text. Then you have to convert the other values also. So suppose we have 4, let's change it to 4, and we have 3, let's change it to 3. So you can see it's so easy, depending on or irrespective of any kind of data set available to you. You can quickly take the data set. If it is in raw format, then you can quickly anonymize it, and you can represent that with numbers so that the actual information is not disclosed. Okay, so that can be done. And conversion into numbers is very important, because until and unless we convert a text into number, we won't be able to apply machine learning algorithms on it. Now, so I hope this is clear with all the participants. Just for a moment, confirm me once in a chat. And here you all can see the stories has been converted into 1, 2, 3 and 4. Similarly, you will have other options. So I just want all of you just manage it and change it into numbers. So here you can see we have the text yes and no. So you can call yes as 1 and no as 0. Okay. So now this also has been converted into numbers. So let's save it. Okay. So for now, if you all quickly observe that we had these 2 columns, stories and driveway, they were in decimal format earlier, but after pre-processing, we have quickly converted into numbers so that our data set is ready for application analysis. Okay. I hope this is clear. Just for a moment, confirm me on chat. Okay, so is there any issue in the video qualities? A student is saying, sir, video quality is not so good today. Can you, I believe you can check back in the settings options and enable the quality of the video. Okay, otherwise, in case if you want me to change my network, so I need to, I think, quickly connect back with the new network. So please confirm me if the video is appearing fine to other participants. Otherwise, I'm going to switch it to another network. Just confirm me. That's why, due to the network, I have just disabled my camera. Okay, so please confirm me once if the voice is audible appropriately and if the video is appearing proper. Just confirm me. Okay, I think it's fine now. Okay, great. Now, so let's see. So here, where were we? We were here. So let us just convert all the other features like stories driveway we converted. Let us just convert the recreational room again. So we have to go here, analyze it. Under the recreational room, let's call it no as 0, yes as 1. Okay. And I am also going to tell you why we have converted this into 0 and 1 and couldn't we use yes and no directly. So that also I'm going to show you once we reach out to the Python part of the code. Okay. So let's go to full basement, convert it into, let's convert no to 0 and yes to 1. Okay. And uniqueness we are already checking in here because there is 0 unique values, no invalid values, no empty values. Hence we are not working towards the empty side of the entry. Otherwise, in case if there is anything empty, then we can quickly replace it with the mean of all the values of that column, or else with the median of all the values of that column. Okay. So because we cannot leave an empty field, neither we can have the text, because if, let's say, if we are going to put a text on a mathematical equation, it's not going to work anyhow. Okay. So alphabets in a mathematical equation only represents a variable, but within that variable we should have a number. And in case if you will try to put a yes into a mathematical equation, it is not going to be processed. As well as if in case if any value is empty, let's say, and you try to put empty values into a mathematical equation, again it is going to be corrupted. The program gets corrupted. Okay. So that is why what we do is we have to convert the values into zeros and ones. Okay. Followed by we have gas hot water. Let's just analyze it. Convert the gas hot water into 0 and 1. Okay, so you can see that machine learning is a very easy process. In case if you have any number of operations available, it is very easy. You can quickly convert the complete table of yes and no with one single change. Okay. Now again, we have air conditioning. Let us just convert this into 0 and 1 again. So no will be represented with 0, yes will be represented with 1. Okay. Now, then finally, the preferred area. Okay. So now you can see what we have got. We have got a complete data set converted into number. So this was the pre-processing stage which we have implemented. Okay. So out of the machine learning stages, the first part of the stage we have completed, which is pre-processing the data. Pre-processing the data means cleaning the data so that there is no empty values in the data set, as well as these values can be represented or converted into numbers. Once they can be converted into numbers, then we can perform analysis on it, because we can put these numerical values in the mathematical equations in order to test or calculate the outcome value. Okay. So suppose I'm just giving you an example. Suppose we are trying to identify an equation which can actually help us use lot size bedrooms and bathrooms and predict the price. So suppose if I give you an example, suppose there is a straight line equation, or we also call it as a linear regression equation, which is the first equation which falls under machine learning. You call it as linear regression equation, and this is also known as a straight line equation. Okay. So linear regression actually works on the concepts where the outcome or the dependent variable is linearly related to the independent variables. Okay. So suppose there is an increase in the independent variable, then there will be an increase in the dependent variable. It could be a linear regression. Similarly, there could be a negative linear regression also. Suppose in case if the value of independent variable is increasing, it could be possible the value of dependent variable may be decreasing. And then again, there will be a linear relation. Okay. So suppose that linear regression relation can be represented with an equation as y is equal to m into x plus c. Now, what we can say is y is a dependent variable, okay, and you can call y as price. Similarly, x could be represented with x1, x2, x3, x4, and so on. Okay, and what these x1, x2, x3, x4 could be. So suppose x1 could be your lot size, okay, followed by x2 could be your bedrooms, and similarly x3 could be your bathrooms, x4 could be your stories. So that means under this equation, at the values of x, we are going to put the specific values. So let's say, suppose I'm going to calculate y. Okay, so I have put y as 4200. Then let's say I have to put the lot size. So I have put the lot size in x. Okay, command Z. We can say, let's say we have put the lot size in x, bedrooms in this, bathrooms in this, stories into this, and so on. Now, using these independent variables, let's say with lot size, bedrooms, bathrooms, we are just taking an example. Let's say using these four values, if we can successfully calculate the value of this price, okay, and the value which comes, and let's say if the value of this output comes is equal to 4200, then we will say that this equation is the right equation which can actually help us predict the price of the house. Okay. So I believe this is clear to everyone that you are going to represent this data and the values within this data on mathematical equations, and using that mathematical equations, you will be calculating the price. And in case if this equation justifies the results, and the results are very close to the price, which means if you have predicted a price, if you have calculated a new price, and that price is equivalent to the previous price, which is already listed in price, then what it can be said? It can be said that the equation fits this data well. Okay, or this fitting is also known as that this specific equation can be used to predict the outcome values. Okay, so I believe this is clear to everyone, and you have got your data ready for analysis. Now what we are going to do, we are going to quickly save it. Okay, so let's go at the top here and save your data set. So once you save it, now you are going to see one thing on the left hand side. Whatever implementations you have done, you can quickly see these changes on the left hand side. So suppose in case if you have made any mistake, and if you want to delete any process or any step in between, and you want to renew that process, So you have this option to manage all the operations on the left hand side. So you can see that we have selected the stories and we converted 2 into 2, 1 into 1, 4 into 4, 3 into 3. So this becomes a categorical variable, n categorical, we call it as n categorical variable. Okay. So we also discuss about how we actually process binary category and n category or a multi-category variable. Okay, which I have just told you a couple of minutes back. Now, followed by that, then we have another values like driveway. So we converted yes into 1 and no into 0 and so on. So you have all the updated options available. So this is a script which has already been made, and you can quickly export this script, and this script can be useful. Let's say in case of a new data comes in, and if it has some text values, a new data of price comes in, let's say, and it has text values, then you can apply this script so that those text values can also be converted into numbers before they get analyzed by the machine learning algorithm. So in order to run this, we have to click on this run option here. So please run it. And once you guys are done, just let me know on chat. So we are going to quickly click on run. Okay. And once we run this, now we are going to get the prepared data set ready. So initially we had, okay, so you can see that we got the job succeeded. We can go to view the details, as well as we can explore the data set housing prepared. But once this is already prepared, we can quickly go to the flow and see how the flow chart has been changed now. So now you can see the flow chart has reached to the second step. So what step we have already implemented? We have implemented the step of pre-processing, where we had the original data set. We have performed pre-processing, and now we have the prepared data set. Okay. So prepared data set is generally used for analysis. Okay. So I hope this is clear to everyone. Just confirm me once on chat so that we can proceed from here. Also, if it is possible to share the screenshot, kindly share the screenshot if you guys are also done with the process where you have took the housing data set or any data set, you pre-processed it and finally converted into a prepared data set. So now this prepared data set is ready for training. Okay, this data set is ready for training. This data set was not ready for training because only the integer columns would have been selected, but all other columns like the number columns would always have been ignored, Okay, and I'm going to show you the difference, that how and why the data needs to be converted into numbers. So just confirm me on chat if you guys all have reached till here. Then I'm going to show you the steps with Python, that how we try to analyze the fact, and in case if it doesn't, then we check what is the issue. Okay. So now, so just confirm me on chat if it is clear till here. Done? Okay, fine. So now let's see. So now you guys are here on the prepared data set. And for now, we will do that quickly on Python also. Okay. So yesterday we have started this script, and let me just quickly share the script link with all of you. You also can open that in collab.research.google.com. I'm sharing the link of the script with all of you so that you can also run it along with me. Okay, here is the collaboratory link. You can open this link and let us execute together. So now, so suppose we have this data set red, and we have already got the bathroom data set, sorry, the house price data set. Now what next we are going to do? Okay, suppose I quickly want to check the stage. Let's say I want to quickly calculate, or let's say from the graph, we have understood a statement, why did it happen? Or let's say we made what happened in data and why did it happen. Okay, I'll do one thing. Let us just quickly see. Let's just quickly calculate the correlation among independent variables and dependent variables. Okay, so why we do check, why do we use correlation? So correlation is a measure to identify relationship between independent and dependent variables. Okay, now what correlation can tell you? Suppose you have this data set. Okay, if I'm going to click on here, let's say on the housing prepared data set. Okay, I'll do what I'll do. I'll just use this one. So I'll go to housing data set. Now in the housing data set, you have two different types of variables. One is the dependent, other one are the independent variables. Okay. Now I'm saying, suppose I want to check, let's say if I have to calculate the price, or if I have to make a machine learning model which can help us predict the price. Suppose we want to make a solution like this. So we want to identify how many of these variables are actually influencing the price, or price is dependent on which of these variables. It may not be possible that it is dependent on all. Okay, it could be possible as well as it couldn't be possible. Sometimes it could be possible there are some positive influencers, it could be possible there are some negative influencers. Okay, so we always want to identify the top influencers who can actually help us predict the price, okay, or predict the dependent variable. So what we do, we try to identify the relation of each column. Let's say I would like to check the correlation of lot size with price. Similarly, I would like to check the correlation of bedrooms with price. Then I would like to check the correlation of bathrooms with price. And correlation means just to identify the relationship between the independent variable and the dependent variable. And the relationship is like whether it influences it positively. Positive influence means something like, in case if the value of lot size is increasing, does the price is also increasing? So it could be possible. Okay, so if I give you an example, let's say आप भोपाल में रहते हैं, ठीक है, भोपाल में आपने कहा कि आपको 1000 गज का मकान चाहिए, ठीक है, मान लो आपको 1000 गज का मकान आपको 1 करोड़ रुपए में मिल गया, ठीक है, फिर आपने कहा कि यार 1000 गज से तो मेरे को नहीं हो पा रहा, मुझे लॉट साइज बढ़ाना पड़ेगा, यानी मेरे को 1500 गज का मुझे चाहिए, ठीक है। अब जब आप 1500 गज पे जाओगे तो नेचुरली सी बात है कि प्राइस बढ़ेगा उसका, क्योंकि अगर कोई घर लेट्स से 1000 स्क्वायर यार्ड्स का है और एक घर 1500 स्क्वायर यार्ड का है इन द सेम एरिया और इन द सेम लोकेलिटी, तो मे बी इट इज अ पॉसिबिलिटी कि जो ज्यादा बड़ा एरिया वाला घर है जिसका लॉट साइज ज्यादा है उसका प्राइस भी ज्यादा होगा, ठीक है। सो ये एक पॉजिटिव इन्फ्लुएंस है। तो ये हमें पता है कि ठीक है, जैसे जैसे घर का एरिया बढ़ता है वैसे वैसे उसका प्राइस बढ़ता है, ठीक है, ये बात आप लोग समझते हैं। बट मैथमेटिकली और प्रोग्रामेटिकली हम इस चीज को कैसे चेक करेंगे कि कौन से वेरिएबल्स हमारे डिपेंडेंट वेरिएबल को पॉजिटिवली इन्फ्लुएंस करते हैं या नहीं, और अगर करते हैं तो कितना परसेंटेज करते हैं. सो फॉर दैट वी मेक यूज ऑफ कोरिलेशन. Okay, so correlation is a measure of identifying the relationships between your independent variables and with your dependent variable. Okay, if this is clear, please confirm me on chat. So let's see. Now we are going to quickly see what is the correlation between lot size, bedrooms, bathrooms, stories, driveway with price. That is what I want to check. Okay. So before I check that, let us just quickly refresh it and just remove it a little. Okay. So I'm going to organize it in this way. Let's say, let's just bring housing data set out. Let us just minimize it a little. I'm going to keep it at the top here. Just I need to show you the data. Okay. Suppose here we have the sample data, and at the bottom, I would like to execute my Python script. Okay. This we are going to keep it at the bottom. So now, so suppose now we are going to check the correlation. So it is very easy to check the correlation among your variables. Okay, and how we can do that? Suppose in the previous layer, we have actually got the data read. So what you can do is, over this data, you can actually execute the command data.correlation. Okay, this is the command, and what it does, data.corr function, it is going to compute the pairwise correlation of the columns. So suppose we have 10, 12 columns at the top, as you all can see here. We have these columns in the data set: price, lot size, bedrooms, bathroom, full basement, and so on. And data.correlation is going to give us a complete pairwise correlation of each of the column, which means we are going to get a correlation in such a way that we are going to get the pair correlation between lot size and price. Similarly with bedrooms and price. Similarly with bathrooms and price. So this becomes the pairwise correlation between the dependent and the independent variables. Okay, so how we are going to call it? Let's have a look. So let's just execute the method data.correlation. Okay, so once you execute data.correlation, you're going to get a correlation matrix. Okay, and I'm going to show you the value of correlation matrix. So let me just quickly keep it on one side of the screen so that you all will be able to understand it a little more well. Okay, so I'm just trying to execute this. So now if we run data.correlation, now you can see you are going to get the correlation values among your data. But now you can see, once we have calculated the correlation, only we are getting the correlation of a few columns, which means, let's say if this is the price, so price is compared with some of the columns, which means we have got the values of lot size. So this value represents that price is 53% dependent on lot size. So this means there is a probability that in case if the area of the house increases, 53% probability is there that the price of the house may also increase. So why is it 50%? Because it could be possible that, let's say there is a village, okay, and in a village, let's say there is a 1000 square yard area is available for a house. It may be of 10 lakhs, but in let's say in the metro city, or in a town or in a city, let's say, what can happen? Let's say if there is a house of lot size of, let's say, 200 square yards, okay, and it could be of 50 lakhs. because that house in the city may be at a very high cost area available. Okay, so it could be possible. So hence the overall data represents that price is 53% dependent on the lot size. It is not necessary that always it is going to be dependent in increment or decrement of the price, but overall price of the house has a dependency of approximately 53%. So there are 53% chances, or else you can see there are 53% cases in the data set in which the price has incremented with the increment in lot size. So we call this as a positive influencer. Okay. Similarly, bedrooms is 36% influencer, bathrooms is 51% influencer, number of garage places for the car is 38%. But where are the other columns? We have to think of this now. Okay. So now we have to think of, in the data, we actually had multiple columns. Now why they are not visible? Okay, where they are? So you can see we have actually we got the lot size, we got the bedrooms, we got the bathrooms. We got bedrooms, bathrooms, and lot size because they were in numbers. But we have not got information about stories, driveway, recreational room, full basement, because they are all text characters. Okay, so you all need to understand about this. So for the integer values, we have got the responses, but for the text values, we have not got the responses. Okay, so this means once you will try to apply any mathematical equation on the data, only the columns with numbers can be executed and can work with that equation. But those columns which does have text, they will not be processed. Okay. So I hope this is clear. Just confirm me on chat once if this is clear to all of you. Okay. So now what we can do, in case if you want stories, driveway, recreational room, full basement to be available in the correlation process, so you have to convert this drive, recreational room, full base, and the other text variables into numbers. Only then they will be available on the correlation plot. Okay. Just confirm me on chat if this is clear to all of you. Okay. So we'll see how we can quickly convert them into numbers. Okay. So let's just clear the annotations and let's just have a new cell. Okay. So now in the UI, it was easy to process, but if we have to perform pre-processing in Python, then we use a library. Okay. Use a library known as sklearn.preprocessing. Okay. We are going to use a library known as sklearn.preprocessing. So what we can do is we can import, let's say, we can import sklearn preprocessing. Okay. So here we have the library sklearn.preprocessing as pp, let's say, and let's run the cell. Okay. Now pp has certain number of methods available. So one such method which we will be using with pre-processing library is pp.label_binarizer. Okay. So there is a class label binarizer, and what this class is capable of doing, it binarizes labels in one versus all fashion. So suppose you have a category like yes and no, then what you can do is you can quickly convert that category of yes and no into 0 and 1. Okay. So that we can do with label binarizer. So how we can do that? So let's say I'm going to use data, and let's say I have a column known as driveway. Okay. So I'm going to use driveway. I'm going to, let's say we have to call pp.label binarizer. Let's just save it into an object LB. because this is the class. And using the LB object, we have this method LB dot fit transform. Okay, there is a method LB dot fit transform in which you are going to pass the value which you want to convert. So let's say in our data, driveway was yes and no. Okay. So currently what am I doing is I'm converting the categorical variable to categorical variable, let's say binary category, which are represented in yes and no into numbers. But when I have to convert n categorical, which means here in this we have 4 categories, and once we have to convert the n categorical variable, then in that case what we do, we either make use of one hot encoding or label encoder. Okay, so we are going to fit the transform and we are going to convert data dot driveway okay. So we are going to convert data dot driveway and we're going to save into data dot driveway. Sorry, data dot driveway. Okay, so let us just quickly print it. If you want to quickly check data dot driveway, so you will be able to see that earlier the driveway field was a yes and no. Okay, but now once you run data dot driveway after the transformation, you're going to get these values represented between 0 and 1. So here 1 is represented because all the top columns in the driveway was yes, 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 yes. And all last 5 columns are also displayed as 1 because the last 5 columns here have also been yes for driveway. Okay, is that clear? So depending on, let's say in case if you want to convert a recreational room, so you are going to get 3 zeros and then 1. And on the 4th location, you're going to get a 1. And in case if you want to quickly test it, let us just quickly have a look. So we are going to fit transform the next value. After driveway, we have recreational room. So we are going to fit transform, let's say data dot recreational room. Okay. And we are going to save it into data dot recreational room. Okay, so we have performed the fit transformation and now we are going to perform data dot rec room. So if I run it now you can see that it is going to be converted into zeros and ones, and this process is very easy. So here in the recreation room it was 0, so it is represented with 0. This was also 0, represented with 0. Third was also 0, represented with 0, and fourth was a 1, so represented with 1. So both ways you can actually convert your text variables into numbers. Okay, so be it user interface wise or be it code wise. Please confirm me on chat if till now it is clear to everyone. Okay, and I have also given you the access to my script, so you all can open my script in your browser and you will get all these codes updated. Okay, so I hope you all are clear that why is it required to convert the text values into numbers, because if the values will be in text, you won't be able to get the correlation matrix, for none of the equations can be applied. But now once I have added driveway and recreational room, then what we can do is we can actually perform data dot correlation. So let's say if I run data dot correlation, and if I run this now, so this time we are going to get 2 more columns added into the result, and these 2 columns added into the result are driveway and recreational room. Okay, is that clear? So you can see that we have got the driveway and recreation room added. So now if you have other number of variables available like full basement, gas hot water, air conditioning, garage places, preferred area, so these also has to be converted into label binarizer, and they should be represented between the value of 0 and 1. Okay, if it is clear, please confirm me on chat. Okay, please confirm me on chat if it is clear to all of you till here, that why is it mandatory to convert your text data into numbers. Okay, so please confirm if you all are done till here. So how many of you are done by converting your numbers? Are you converting your text values into numbers? Yeah, so Rec Room is nothing but one more feature. It's a recreational room. You can consider it as a drawing room in a house, because we are actually representing the case of a real house here. So let's say this is my another page. So suppose this was your data set of multiple houses in the Bhopal city. So what we are trying to do, we are going to perform machine learning analysis on the house data set of Bhopal. So suppose we have got the price information, area information, number of bedrooms in that house, and all other information like recreational room, which is a drawing room. Okay. But the problem was in this original data, price and area were written in numbers, and bedrooms and bathrooms were also written in numbers, but other facilities like does the house has a driveway or not, does that house has a drawing room or recreational room or not, does that house has basement in the house or not, does that house has central gas hot water air fitting or not, or air conditioning or not. Okay, so these are the Boolean responses like yes and no. So we have to convert them into numbers, and if we don't convert them into numbers, you won't be able to identify their relationship with the price. Okay, so suppose here you can see that after I have converted rec room, garage places from yes, no to 0 and 1, and now we are able to calculate the correlation between them. And correlation means, in case I am going to draw a diagram, I hope you all will be able to understand with that diagram better. So suppose I have got a graph somewhat like this. Okay, and I say, let's say at the very bottom there is the area of house, and you can also call it as lot size of the house. Okay, and here on the y-axis we have the price. Okay, so now we say, suppose we increase the area. Okay, suppose we are increasing the area of the house. So as soon as we increase the area of the house, it could be possible that the price of the house will also increase. So this is a relationship between price and let's say lot size. Okay, and this relationship is represented here in this value, that price and lot size are actually dependent on each other, or you can also say with increase or decrease in the lot size, there will be an increase or decrease in the price. And what is the probability? So there is a 50% probability. So when it comes to 50%, so you can have a graph somewhat like this. It could be like this, that there would be sometimes less, sometimes more data would be there. But in general, it's going to be, let's say, a linear data, which means on average number of cases, as soon as we are increasing the area of the house, the price of the house is also increasing. Okay, is that clear? Please confirm me on chat now. Okay, so I hope everybody is clear with the correlation, and correlation is very useful for you. So let's say if you guys are working on a problem statement, okay, and you don't know what are the important features, those who are actually dependent on this problem. Okay, so how you can identify that? You will be able to identify that using your correlation analysis. Okay, I hope this is clear. Okay, so just confirm me once again if this is clear. Okay, now let's see what next we are going to do. Okay, now, so let's come to the next point. In the next point, once you have got the correlation analysis done of various different features, now what we want to identify all the exact variables which are actually responsible in prediction of the price. Still, there are some columns missing, okay, and the columns are missing because they are available in the text format. So let us just convert all of them into numbers. So the way we converted all of them into numbers in data IKU, similarly we are going to implement let's say similarly we are going to convert them into numbers in Python also. Okay, where is that script gone? Okay, here we have. Okay, now here. So what I'll do is I'll take you to the housing data set again. Okay, and now, so you have got lot size, you have got bedrooms, bathrooms, driveway. We don't have stories at the moment. Stories, as you already know, stories was an n categorical value. So if I show you, stories does not have binary values. Story has n categorical values. So when you have n categorical values, how we process actually? So you can see that here we do have 4 types of values here, 2, 1, 4, and 3. So when you guys have to convert this into numbers, you need to use a technique known as one-hot encoding. Okay. So in one-hot encoding, what is going to happen? for the specific stories factor, 4 different values like 1, 2, and 3, 4 will be represented as columns, and their corresponding values for that stories row will be represented at either 0 or 1. So before you understand that, let me just quickly show you the Wikipedia article where you all can understand about one hot encoding. Okay, so let's see. We have one hot encoding here. So what is one hot encoding? You can quickly search that in Wikipedia. There is a very nice article available on one hot encoding here, and I'm sharing that article with all of you. Okay. So here on chat, I'm just transferring. Okay. Now let's see. So what next we are going to have? So suppose what is one hot encoding? So consider a case where you have n categorical value. Okay, n categorical means there is a stories column, and in that stories column we have 4 different categories. One category belong to 1, second is 2, third is 3, fourth one is 4. Okay, because there are 4 stories of a building. Let's say there is a building with 1 story, another building is of 2 story, another building is of 3 story, and then finally a 4-story building. Now we have to identify and convert these n categorical into numbers. So either we can convert it into 1, 2, 3, 4. That can also be possible, which I have already told you. You can also use one hot encoding, which is also a new technique and generally used. And there is one more, which is label encoding. Okay, these are the 2 techniques with which you can convert a text into a specific label. Okay, like this. So suppose you may be having different n number of categories, and you can convert those categories into representing into 0, 1, 2, 3, 4. That can also be done. Okay, both ways it is possible. So suppose you have some text values in your data set and they are more than 2. They are not binary, they are more than 2. In that case, you can convert them into numbers using label encoding technique. And once they are converted into numbers, you can put it into the data and perform the analysis. Okay. So I hope this is clear. And label encoding is also very easy process. So how it can be generally done in label encoding, you have to do a couple of steps like this, let's say. Okay. So suppose we have a specific data frame. So what we can do like this, you can quickly initialize, let's say, the label encoder. Label encoder is also available under the pre-processing library, which we have already imported. And what you can do is, using that label encoder, you can select your data frame, whatever data frame you are actually using. Okay, and then finally you can use the fit transform method. But in that, you have to actually define the types of the columns or whatever values in the form of a set. You have to define the values, and then those set values will naturally be converted in a lexicographical manner into 0, 1, 2, 3, 4, 5, like that. Okay. So now here you can see that what generally has been done. Initially, you have to define all the different categories which you have, like arc, beam, truss, cantilever, whatever it is. And in our case, it is 1, 2, 3, and 4. Okay. So we have to define all of that. Then you have to create a data frame with those specific types, and you're going to define a column name for it. So now you're going to get the category. You will use label encoder technique. Now, with that label encoder technique, what you are going to do, you're going to perform fit transform by providing that data frame along with the column name. And then you're going to get that categorical value converted. Okay, so that can be done. So let us just quickly check back. So in case if you are having, let's say we are here in the housing data set. Okay, so there are 2 ways. One way is one hot encoding. That also I'm going to tell you, which we generally use because it is very easy process and a quick process, as well as you can also convert label encoding also. So here what we are doing is converting n categorical values, text values into numbers. Okay, so how it can be done? So you have to import label encoder. So you're going to use the pre-processing library and you can use label encoder. So label encoder is also, okay, let's call it as LE or LBE, label encoder. Okay, you can quickly run that label encoder, and once you have to convert that, what you can do is you can use label encoder, you can use fit transform, and then you can pass in the column, let's say data, and from the data column we are going to pass its stories value, or you can also directly call it like this, data dot stories. Data dot sto, oh sorry, they are in lower cases, data dot stories, stories. Okay, so we've got a series here. You can quickly fit transform that. We can run and quickly check back. So now you can see that that specific array with category 1, 2, 3, 4 has been quickly transformed into the value of 0, 1, 2, 3, something like that. Okay, for all the specific values. So suppose in stories, okay, we got these values represented with these are arranged in lexicographical manner. Okay, so you have 1, 2, 3, and 4. So 0 will be F. Okay, 0 value will be 4. Then you will be having 1 will be for 1, 2 will be for 3, and 4 will be for TWO. So accordingly, using the lexicographical order, these encodings are going to be converted. Okay, so let's say if I show you, we have 2, 1, 3, and 4 also. Okay, so 4F comes first, so you are going to get fourth value will be treated as the 0th value. So if we count from here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we are going to check the 9th value from here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the 9th value. So your 4F is going to be represented with 0. Okay. Then you are going to have 1. Your 1 is going to be represented with 1. Then you are going to have 3 will be represented with your 2. Okay. And your 2 and 1. 2 will be represented with 3. 1 will be represented with 1, and so on. Okay, so we have identified about all 1, 2, 3, and 4. So quickly you can also convert that into numbers. Okay, so now, and in whatever value you convert, that doesn't matter at all. We just have to take care about if that feature is responsible for prediction of the price or not. Even if the values gets changed, it doesn't matter at all, because finally when you will be performing data analysis, most of the time you will be getting anonymized values, and mostly the values will be between a range of 0 to 1. So there is no need to match that. One should match exactly with 1. Okay, so that is not required at all. So now what we are going to do, we are going to quickly save that into data.stories, data.stories, stories. Okay, and you're going to get that saved. So we have got stories converted also, and there were a few columns left which I would like you all to convert quickly here. So we have already converted stories, driveway, recreational room has been converted. Let us just convert all the others also: full basement, gas, hot water, air conditioning, and preferred area. So let us just quickly remove these two, and let's just fit the transform. So we are going to call lb.fit transform data dot full basement. Okay, we are going to save that into data dot full. Okay, data dot full basement. Similarly, we are going to convert gas hot water lb dot fit underscore transform, and then you will be having gas hot water. This is from data. You can quickly store that into data dot gas hot water. Okay, then you will be using lb dot fit transform. You will be converting air conditioning, data dot air conditioning. You can save it into data dot air conditioning. And finally, we will be having preferred area. So you are going to set lb dot fit transform. Okay, and in lb dot fit transform, you are going to define data dot preferred area, and you can quickly save that into data dot preferred area. Okay, so now you can see that all of your columns will now be converted into binary. So 0 and 1 will be converted into binary, and we have got the stories column also. I'm going to move it up. I'm going to convert stories column also. And finally, now if I'm going to calculate the correlation plot, so you can see that now all of your columns will now be represented. So now we can actually calculate that price is dependent on what percentage with respect to other independent variables. Okay, so you can identify price depends on lot size for 53%, 36% on bedrooms, 51% on bathrooms, 6% on stories. So it doesn't matter. So suppose if you have a 1-story building or a 2-story building or a 3-story building or a 4-story building, it says it is not it is not influencing the price of the house much. Okay, followed by in the driveway, recreational room, full basement, gas hot water, air conditioning, garage places. So somehow gas hot water is not much positively influencing, which means कि अगर किसी घर में बाय डिफॉल्ट गैस पाइपलाइन लगी है तो ठीक है, नहीं लगी है तो भी उससे ज़्यादा कोई फर्क नहीं है. अगर किसी को चाहिए होगी तो लगवा लेगा, उससे प्राइस, घर के प्राइस के ऊपर ज़्यादा फर्क नहीं पड़ रहा. ठीक है, इसी तरीके से अगर किसी घर में बेसमेंट है या नहीं है, उससे भी प्राइस के ऊपर ज़्यादा फर्क नहीं पड़ रहा. बट मेजरली प्राइस के ऊपर किन चीज़ों से फर्क पड़ रहा है? घर का एरिया कितना बड़ा है लॉट साइज से, घर में बेडरूम्स कितने बन पा रहे हैं उससे, बाथरूम्स कितने बन पा रहे हैं उससे फर्क पड़ रहा है. ठीक है, अलॉन्ग विद दैट ये ड्राइववे और ये सब तो ज्यादा बड़ी वैल्यूज नहीं है, गैरेज प्लेसेस और घर आपका प्रेफर्ड एरिया में है या नहीं, तो ये कुछ हाईली इन्फ्लुएंसिंग फैक्टर्स हैं. ठीक है, लेकिन आप बाकी सारे फैक्टर्स को कंट्रीब्यूट करके एक्चुअल प्राइस कैलकुलेट करोगे कि घर का प्राइस क्या होना चाहिए. ओके, सो अब मान लीजिए इसी तरीके से हमने 500 घर की एंट्रीज कर ली, और अब हमें मशीन को सिखाना है कि वो अपने आप समझ जाए कि किस घर का प्राइस कितना होना चाहिए. हमें यहाँ पे इफ एल्स लॉजिक लिखने की जरूरत ना पड़े. ओके, सो उसके लिए अब हम मशीन लर्निंग की एल्गोरिथम्स को यूज करते हैं कि हमारे पास आउटपुट डेटा है, हमारे पास इनपुट डेटा है. अब इसको यूज करके हमें आइडेंटिफाई करना है कि ऐसी इक्वेशंस को हमें आइडेंटिफाई करना है, मैथमेटिकल इक्वेशंस को, जो कि इस डेटा के इनपुट्स को इक्वेशन में डाले और आउटपुट कैलकुलेट करे और वो आउटपुट प्राइस के बराबर आए. ओके, समझ रहे हो मेरी बात? सो व्हाट वी एक्चुअली हैव टू डू, we have to work out on the system in such a way where you all will be calculating all these independent variables, and using these independent variables you will be predicting the price of the house, and the price of the house should be much closer to the actual prices. So we are going to shortlist that mathematical equation which can help us in this manner, which can actually take the independent variables and can predict the price of the house accurately. That is what we need to build up. Okay, but from here we will continue in our next session, that is tomorrow. Just confirm me on chat how many of you all how many of you are done with performing the correlation analysis on all the factors, and you all are clear with the process of pre-processing the values from null values or from text values to integers. So you guys are clear with the pre-processing stage. Next, we will be working on transformation, then mining, and finally you will be working on interpretation and evaluation, and you're going to make use of your telecom data set. Okay. And once again, I'm just sharing the script to all the participants so that in case if somebody has missed the code which I have written, you can quickly open this file in your computer, click on run in playground, and you can step by step execute the script which I have coded here. Okay, so that will actually help you implement the concepts and understand the concepts better. I'm just sharing that on chat. Okay, so guys, I believe this is clear to everyone. So it's very easy. So you got a raw data set, and we have taken this raw data set just to make you all understand that you can make any survey. Out of the survey, you can collect the data, and you can quickly convert that data into numbers. Once they are converted into numbers, you can quickly check back what are the features which are actually responsible in prediction of the price or the dependent variable. ओके सो जैसे मैं अगर आप लोगों को एग्जांपल दूं, आप लोगों ने बहुत सारे वेबसाइट्स देखे होंगे, जैसे आजकल आती है cardekho.com या droom.com. तो ये सब क्या करते हैं, इनके पास प्रीवियस कार्स होती हैं, मतलब प्री ओन कार्स ये लेते हैं. प्री ओन कार्स का एक ये प्राइस प्रेडिक्ट करते हैं कि इतना प्राइस होना चाहिए. तो उन्होंने क्या किया, कार्स की कई सारे फीचर ले लिया कि इंजन कितना पुराना है, ठीक है, कलर कैसा है, कितने बार एक्सीडेंट हो चुका है, इस तरीके से बहुत सारे फीचर्स, क्या इंश्योरेंस इसमें है या नहीं, ठीक है, इस तरीके से उन्होंने बहुत सारे फीचर्स काउंट कर लिए. अब जब कोई भी कार का डेटा आता है उनके पास, वो उस अपने मशीन लर्निंग के मॉडल में डालते हैं और क्विकली उसको प्रेडिक्ट कर लेते हैं दैट व्हाट शुड बी द प्राइस ऑफ दिस कार. ओके, सो देयर इज नो वन सिटिंग मैनुअली हु इज कैलकुलेटिंग ऑल दैट. सारे फीचर्स आइडेंटिफाइड है मॉडल के अंदर, वो बस वैल्यू एंटर करी और एंटर किया, मशीन लर्निंग की इक्वेशन से बता दिया तुरंत कि क्या प्रेडिक्टेड प्राइस होना चाहिए. एंड दिस इज हैपनिंग विद ऑल द केसेस टुडे, बी इट housing.com, be it droom.com, or there are so many applications and products available today. Okay, so this is a very useful process which is very important for all of you, as well as when it comes to the live projects. When you work in an industry, let's say if you guys are facing a problem, so how will you identify what are the exact reasons behind this problem? So if you can implement such approach, you will be able to identify that what are the exact reasons using which something is happening or something is not. Okay. So I hope if you all have liked the session, so kindly hit the like, as well as if you have any queries, please send us the query on chat here. I have already shared the script with all the participants. Kindly practice it. It is very simple process. You can do it both ways. आप डेटा IKU में जाके आप उसको लाइव भी प्रोसेस कर सकते हैं. आपने अपने डेटा सेट को इंपोर्ट किया, इंपोर्ट करने के बाद में आपने सारी वैल्यूज को मैन्युअली मॉडिफाई कर दिया, चाहे वो वैल्यूज बाइनरी थी, यस नो की, या फिर एन कैटेगरिकल थी, 1 2 3 4 की, वो आपने मैन्युअली चेंज कर दिया. सिमिलरली वही काम आपने पाइथन प्रोग्रामिंग से भी कर दिया. आपने डेटा सेट को रीड किया, तुरंत आपने लेबल बाइनराइजर प्री प्रोसेसिंग लाइब्रेरीज को यूज करके आपने उसे कन्वर्ट किया into 0 and 1 as well as into 1 2 0 1 2 3 also. Okay, now once you have got the mathematical data ready, आपने उसके ऊपर कोरिलेशन एनालिसिस कर दी. कोरिलेशन एनालिसिस का फंक्शन बहुत ही इजी था. आपने डेटा, जो भी आपका डेटा फ्रेम है, उसे सेलेक्ट किया, कोरिलेशन का फंक्शन अप्लाई किया. जैसे आपने उस फंक्शन को अप्लाई किया, आपके पास पेयर वाइज मैट्रिक्स आ गई. उस पेयर वाइज मैट्रिक्स के अंदर अब आपके पास क्लैरिटी से आपको ये इंफॉर्मेशन अवेलेबल है कि प्राइस कौन कौन से अदर फैक्टर्स से कितना परसेंटेज इन्फ्लुएंस हो रहा है. ठीक है, एज वेल एज नॉट जस्ट प्राइस, आप बाकी सारे कॉलम्स को भी देख पा रहे हो कि कौन से कॉलम्स कौन से दूसरे वेरिएबल्स को कितना परसेंटेज इन्फ्लुएंस कर रहे हैं। कल हम इसके लिए ग्राफ बनाएंगे जिसमें आप समझोगे कि ग्राफिकली हम इस इंफॉर्मेशन को कैसे व्यू कर सकते हैं एंड देन यू विल बी using this for transformation purpose, and finally you will apply machine learning algorithms, quickly compare those algorithms, and once you guys are done with comparison of those algorithms and once you have got the correct algorithm, then you can actually build up a web application and integrate this model. Okay, as well as we will be working towards the telecom data set. There you will be actually creating some good quality maps, and you will be trying to identify what all telecom data and mobile phones are available in which country. So all that thing you will be doing in the upcoming session. So let's have a session tomorrow, 2 p.m. to 4 p.m. And till then, see you everyone. Have a great day. Any questions? Feel free to post your questions on chat. Anybody? Any questions? Just let me know on chat if you guys have any questions. Okay, great. So I believe there are no such questions. Even in case if you guys have any questions, now we have extended Talk to Mentor support on our website. So the Talk to Mentor support will be available from 12 p.m. to 8 p.m. in the evening. Earlier it was only for 2 hours from 12 p.m. to 2 p.m. Now we have extended the Talk to Mentor facility from 12 p.m. to 8 p.m. So if you guys have any queries while practicing this code or while practicing this application later at home, in case if you guys get any queries, feel free to come to the website hackwither.in and you all can post your queries there, and the mentors are available there. They can quickly have your queries and they can help you out with the solutions. Okay. Okay. Yeah, and Abhinay is asking, sir, can you show a demo for filling the empty cell in the data set? Yes. So what you can do is filling an empty cell is also pretty easy concept. That is just you have to identify with the empty function and dot fill na. So here is the function. I'll just quickly show you that. As well as tomorrow I'm going to take up some empty columns and I'll show you that so that everybody will be able to understand. But let me just quickly give you a quick understanding of that, how you can do that. So suppose you are here, okay. So what we do, there are a couple of options here. There is a function known as fill not available, fill na. Okay, what this fill na can do, using this you can fill the empty values using the specified method, and you can define the name of the method. As well as what we can do, what methods we have, there are 4 types of methods: backfill, bfill, padfill, and ffill. As well as in case if you want to fill with a median value, so what you can do is, let's say we have got data. Out of the data, let's say I have bedrooms, let's say. Okay, so let's say I have bedrooms. Okay, I'll just quickly check. So let's say if we have the bedrooms data, and if you quickly want to calculate the mean of the data, you're going to get the calculated mean for that bedrooms. Now what you can do is, you can, let's say in case if you want to fill any non-empty values in the bedrooms, so we are going to save that into, let's say, bedrooms mean. Oh, I'm sorry, I have not shared the screen. Okay, here, somewhat like this I'm saying. So suppose we have data, we have actually calculated the bedrooms of the mean, and suppose in this bedrooms column, it may be possible that there may be some empty values. Still in this database, there is no empty values exists, but you can actually find not available. Okay. So let's say in case if you want to see data of bedrooms, okay, and you can actually find not available. Okay. just call it like this. Okay, so you have fill not available, using which you can actually quickly fill the values, and there are actually a couple of methods are there. One is empty, with which you can actually check whether that property is empty or not, as well as I'll just quickly show you. There are a couple of options. One is drop NA in case if you want to delete the empty values. One is your fill NA in case if you want to fill the empty values. And there is one more option with which you can actually identify if there is any empty. So is NA is the function. So it is going to give you a truth table. Let's say I'm going to quickly check in case in the data, if we are going to get any true value at any of the specific column space, that means that is empty. And in case if it shows false, that means it's not empty. But somehow, suppose we say that in case if in our data under bedrooms, if any value is empty, we can quickly check back with is NA. And we can see false, 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 false at the moment, which means none of them is empty. But still, if you want to fill it, let's say bedrooms dot fill not available. So within this fill not available, what you can do now, you can actually pass whatever replacement you want to do. So you can fill that with bedrooms underscore, let's say mean, and you can run that, and you can quickly fill that value. If there would be any empty value available, that will be filled with 2.99. But since there were none of them were empty, hence we have got the actual values returned, like 3, 3, 2, 3, 2, whatever it is. Okay, so this is how you can actually identify the empty values, and you can, if there are empty values in the data set, you can fill them, or else there is one more option in which what we do, we delete the row. So in case if you have something like empty, you can also drop not available. Okay, so if there will be any empty values, we can drop the data also. But it's not good to drop in case if you have less number of observations. So suppose in our data set we have only 546 observations, so it's not a good idea to delete it, but to drop the not available. But somehow, let's say in case if we have a big data, we have billions of entries available. So now in that billions of entries, it's not a good choice to, no, it's a good choice to drop it in case if you want. Okay, it doesn't matter at all in case if you have billions of rows available. But suppose if the data set is small, then it's always good to fill it with the appropriate values. Okay, so I think this question is also clear. And any more questions on chat? Feel free to ask your questions in case if anybody has any. Where is my, here. Okay. Yeah, so I have actually shared my screen. Any more questions? Just let me know. Okay, so I believe that's all for the day. Let's catch up tomorrow, and we'll continue from here. Thank you so much, everyone, for being available. And sir, if you want to say anything, please. Sir, I believe your mic is muted.
Yeah, sir. Okay, thank you so much, sir. Thank you, Devanshu, sir, for your valuable efforts. Today, you have discussed many important concepts regarding machine learning using Pythons by various examples. I am sure that all the participants of this workshop definitely will be benefited by your deeply efforts. And one more thing, I want to say that you have given the opportunity to talk to mentors. So this is very helpful for the participants. So thank you so much, sir. Okay, sir, for today's session.
Okay, sir. Thank you, sir.